Good morning students. Today we will do the next topics of the metallurgy. Now what is metallurgy? Metallurgy is the process of extraction of the metal from its ores, and we will today do the steps involved in the metallurgy. First is the crushing and the grinding. Crushing and the grinding. When we take the ores from the mines, they are in the form of big lumps, and then those lumps are crushed in the big jar crushers. They are crushed in the big jar crushers, and then the ore is converted into the powder form in the ball mills. Why we convert the lumps of the ores into the powder form? Because powder form have the large surface area and hence the reaction is fast. One question has been asked in the exam that which will burn quickly, 1 gram of pulverized wood or 1 gram of the simple wood. Pulverized wood mean the wood in the powdered form. तो आंसर इसका ये है बच्चे कि 1 ग्राम जो हमारा pulverized wood है that will burn quickly as compared to the simple 1 gram wood. The next step is the concentration of the ore. Next step is the concentration of the ore, and it is also known as ore dressing and benefaction. Ore dressing and benefaction. The first process is the first process of the concentration is the hand picking. Hand picking. If the impurities are large enough or the particle size of the impurities is large, then they can be hand picked and removed from the ore. The second step is the gravity separation process. Second step is the gravity separation process, and it is also known as the leviation or the hydraulic washing. Now what is the gravity separation process? In this process we separate the ore from the impurities by washing the ore, and this process is mostly involved for the heavier ores, and impurities are lighter in nature, and the ores which are concentrated by this process are the iron and the tin, and also native ores of gold and silver are also separated by the gravity separation process. Now how the washing is done? Washing is mostly done on the Wilfley table. Washing is done, hydraulic washing or the gravity separation is done on the Wilfley table. Now what is Wilfley table? Wilfley table is just like the given in the diagram. It is the made up of the wood, but it is slanting in position, and it has grooves inside it. Grooves are what? Grooves are just like the depressions in our hands, are the somewhat deeper depressions. Grooves are what? They are the depression, just like the depression in our hands. They are the depressions in the this Wilfley table. And the pulverized ore or the grinded ore or the powdered ore is kept on the trays, and a fine stream of water is passed over them. The impurities are washed away on the table. Table is kept in the slanting position. It is itself in the slanting position, and the impurities are washed away, and the heavier ore comes in the grooves. Heavier ore comes in the groove. जैसे मैं आप एग्जांपल आपको घर की बताऊंगी, किचन की. जैसे हम चावल धोते हैं तो उसमें जो फाइबरस पार्ट है वो ऊपर आ जाता है, और चावल क्योंकि उनकी ग्रेविटी ज़्यादा है या उनकी दे आर हैवी, तो वो नीचे रह जाते हैं और फाइबरस पार्टिकल जो हैं वो पानी के साथ बाहर चले जाते हैं. एंड द ओर्स विच आर कलेक्टेड इन दिस ग्रूव्स, when we give the rocking movement, ऐसे थोड़ा सा इसको हिलाते हैं, rocking movement देते हैं, the ore is collected sidewise, and this is the concentrated ore. In the last I will again say that by the gravity separation process we pass a stream of water and the lighter impurities are washed away and the heavier ore remains on the Wilfley table. The third process of the concentration of the ore is the magnetic separation process. It is the magnetic separation process. Now, in the magnetic separation process, either the ore or the impurities should be magnetic. Either the ore or the impurities should be magnetic, and mostly it is used for the magnetite, that is the ore of the iron, chromite, this is the ore of the chromium, and pyrolusite, and it is the ore of the manganese. Magnetite, ore of iron, chromite, ore of chromium, pyrolusite, ore of the manganese. And these are all magnetic ores. Now, what is the process? I will explain the process. Here in the diagram, we have a conveyor belt, a funnel, and the two rollers. One roller is normal roller and another is the electromagnetic roller. We put the finely powdered ore in this funnel and the ore comes from the funnel on the conveyor belt, and when the conveyor belt rolls, this conveyor belt rolls, the ore also rolls along the conveyor belt. And when it comes to the electromagnetic roller, it is the magnetic ore is attracted by the electromagnetic roller and it forms a heap below the electromagnetic roller. And the impurities also form a heap, but the impurities heap is formed away from the electromagnetic roller. Now, sometimes in the case of tin oxide, that is the tin stone, impurities are magnetic and tin stone itself is non-magnetic. And here the impurities are of iron tungstate and manganese tungstate. We can say tungstate of iron or tungstate of manganese, and both the impurities are magnetic, and the main ore, that is tin stone, that is non-magnetic. And here when the conveyor belt rolls, the magnetic impurities comes down the electromagnetic roller and the tin stone forms the heap away from the electromagnetic roller. In this way, the ore is separated from the impurities whether they are magnetic or non-magnetic. The fourth method is the froth flotation process. Fourth is the froth flotation process. Now, in froth flotation process, what happens? Mostly this process is employed for the sulfide ores. Mostly this process of froth flotation process is employed for the sulfide ores. But what we do, that is, we take a tank and put the this oil, pinyl, water, and the pulverized ore in this tank, and it forms a suspension, and a rotating pedal is kept or adjusted in this tank, and when we rotate this pedal, the air is also compressed air also moves in the tank. And this method is based on the fact that is the preferential wetting of the ore with the pinyl and preferentially preferentially wetting of the impurities with the water. As impurities are wetted with the water, they come down the tank, and as the ore is wetted by the pineal, that comes as a froth on the top. When the air comes, when a compressed air is passed, the ore of the the ore forms the froth with the pine, and it comes on the top of the tank, and the froth is collected or froth is skimmed off from the top in the another container, and thus the ore is separated from the impurities, as impurities remain behind. Now sometimes what happens, there are two or more ores. There are two or more sulfide ores. If the two or more ores are there, sulfide ores are there, then we add some depressant. We add some depressant, and that what is the function of the depressant? Depressant stops the formation of froth of the one ore. For example, we take the two ores, that is lead sulfide and zinc sulfide, and sodium sulfide as a depressant stops the formation of froth of zinc sulfide, and zinc sulfide forms a complex with the sodium cyanide, and that remain in the aqueous solution in the soluble form. This complex, that is of the tetracyanozincate, sodium tetracyanozincate, that remains in the soluble form in the container, and lead sulfide form the froth. For stabilization of the froth, we add the froth stabilizers, that is the aniline and the cresol. Aniline and cresols are the stabilizers, and froth collector or froth formers are the pineal and the fatty acid. Again, I will explain the froth flotation process because it is very important. It comes in the exam, and first of all, it is mostly used for the sulfide ores, and the principle is that the ore is preferentially wetted by the pineal, and the impurities are preferentially wetted by the water, and the impurities as wetted by the water are heavy and remain at the bottom, and the ore which is wetted by the pineal, that forms a froth on rotating the pedal and passing the compressed air inside the tank. The froth is formed, and froth of the sulfide ore is skimmed up from the top and collected in the another container, and we sometimes add froth stabilizers, and that is the aniline and cresol. And if there are two ores of two sulfide ores, then we add the depressant, that is the sodium cyanide. It is also asked in the exam, what is the depressant in the froth flotation process, and the depressant in the froth flotation process is the sodium cyanide. It stops the formation of froth of the zinc sulfide, and thus we can separate the lead sulfide from the zinc sulfide, as zinc sulfide remains in the form of the complex in the solution, and the froth of the lead sulfide is collected in the another container. Thank you, students. Tomorrow I will explain about the leaching, that is the fifth process of the concentration. Thanks.